All right. So now let's look at this. We talked about this Friday about how we plugged it in. So remember it was called the greatest integer function. So if we put in basically a decimal or a fraction, it would take it to the greatest integer that was less than or equal to whatever that happened to be. About the graphs that you're going to do for me tonight. What I was saying, on your graphs, when you do those, okay, you're going to do like 6 of them tonight, do it all on graph paper. Okay, every single last thing on it, do it on graph paper for me. Okay, that's going to make it easier for me. On Friday, I'm going to check them. Okay, and I'm going to go over everybody's individually with them. So when I check them for grade, I'm not just going to sit there and grade it in front of you. If you miss something, I'm going to help you fix it before you turn it in. Okay, now, and so we won't be going over them in class a whole lot. Now, let's get back to this. And so remember, anything that we put in, we're going to do the greatest integer that is less than or equal to this number that we put in. Now, this leads to a really funny looking graph. Now, normally with these parent functions here, we start with a t-table. Okay. Now, this t-table is going to be really funny looking though. Okay. Now, this one, it really doesn't matter so much where you start, but more so how you write the x values. Okay, so the first values I'm going to start with is I'm going to think about this. Okay, and just go with me on it. We're going to look at an inequality instead here. Okay, so let's talk about, well, what does this mean? What numbers am I talking about? Right, 1.1, 1.2, 1.3. So this means what? All the numbers that's in between 1 and 2. Okay? And so what I want you to think of this as would be like we were saying, 1.1, 1.2, 1.3, 1.4, 1.5, all those numbers. Now, if I put those numbers into the greatest integer function, the greatest integer less than or equal to, and I'm going to think of this as 1 point something, okay? The greatest integer less than or equal to 1 point something is going to be what? 1, okay? Now, let's keep this going, and let's see if you can kind of think of what the next one would say. So the next one, instead of 1 point something, what would it be a good thing to call the next one here? 2 point something. And so 2 point something would be in between 2 and 3. And so we're going to include 2, so that means the equal to goes on the 2, but we won't include 3. Because think about it, right, we don't include 3 because the greatest integer less than or equal to 3 would be 3. And I want this to be 2. So the greatest integer less than or equal to 2 point something would just be 2, right? Okay, now let's keep going. A lot of times, this is all you're going to need is just 2 of them. We'll do a third one just for this. So that's basically 1 point something, 2 point something, 3 point something. Okay, so that would be the numbers that's in between 3 and 4, but I'm not including 4, right? All right, so in between 3 and 4. So this would be 3 point something. So the greatest integer less than or equal to 3. Right, so the greatest integer less than or equal to 3 point something is just going to be 3. Okay, now how we graph this is it's like real finicky. Okay, you have to watch real close. In fact, I'm gonna do it with a pencil and I'm gonna zoom in real as much as I can here. Okay, and let's look at the graph. All right. Yes. Okay. Now, so let's look. All right, we're going to look at the x values that's in between 1 and 2. All right, so I'm looking at this space right here, right? So in between 1 and 2, is going to be a little line segment right there. Okay. Hang on just a second. All right. So let's switch to this graph. So what I want to think about here, this is the numbers in between 1 and 2. So that would be from here to here, right? Now, when I'm in between 1 and 2, what's my y value? 1. Okay. So what I'm going to do, I'm going to go up to the y value of 1, and I'm going to draw a segment that goes in between 1 and 2, like that. Okay. Now, somebody kind of mentioned it. We have an open and a closed circle thing, right? So what do you think is going to happen at 1 right there? Right, it's going to be a closed circle. Right, it includes 1. But then at 2, it's going to be open. Now, so what we get is like a little line segment, or it's called a step. Okay, you'll see why it's called a step in just a minute. Now, talk to me. Did y'all kind of follow that okay? It's 1. Okay. All right, you may kind of go through it again for you. All right, this is pretty complicated graph. So again, you got to know that this means in between 1 and 2, right? So in between 1 and 2 would be in this range right here. So I'm going to draw a line segment in between 1 and 2, but I'm going to do it where the y value is 1. So that's why I went up 1 right there to put it. Okay? And because it was equal to at 1, we put a closed circle at 1 because that would be 1. And then on 2, we put an open circle. Okay? Now let's see if you guys can kind of get the next step. All right, yeah. All right, so on the next one, now we're going to be in between 2 and 3. So that would be between there's 2 and there's 3, right? So we're going to be in between there, but what's our y value? 2. So this would be a segment right here, wouldn't it? Okay, so right, and that's why we're going to call it something here. And so in between 1 and 2, so I include 2, so that means this would be closed. But then at 3, I don't include 3, so this would be open. Now, are y'all seeing a pattern there now? Yeah. And so the greatest integer function is also called the step function. Okay? Because it's going to look like little steps going up. Now, here's the thing. Once we get a pattern onto this, we don't really need to go back to the graph to look at it, or to the t-table. All we need to do is follow a pattern. So what am I going to see right here if I just keep on with a pattern? Right, closed circle, and then a segment, and then an open circle. Okay, closed circle right here, segment, open circle. And somebody's always going to ask, well, how far do I need to go? However big you make your graph is how far you need to go. Okay, now I'm going to stop mine right there. Now I need to go backwards too. Okay, Angela, question? Yeah. Mm-hmm. And let's talk about why didn't I not just choose one single value? Well, the greatest integer function is going to take any decimal and take it back to the integer that's smaller than that, right? And so anything that falls in between 1 and 2 is going to go back to 1. So instead of showing a single value, I'm showing a range of values. So I'm basically showing the number 1 and all the decimals that go behind 1. Okay? Now, let's go backwards with this. So right here, what am I going to see if I'm just following my pattern? All right, open circle, segment, all right, and then closed circle. And there again, however big the graph is how much I want y'all to fill in, okay? So that's all I got on my screen. I'm going to stop. Okay? Now, did y'all see how that kind of works there? This is how you graph the integer function, also known as now the step function. Yeah, always go backwards. Usually what I try to tell you on this one, usually when I give it to you on the test, I give you a smaller graph to graph on, so you don't have to do so much. Okay.